All right, this video we're going to discuss the variance of a variable from a frequency distribution. And at the end, we're also going to throw in the standard deviation of a variable from a frequency distribution. Let's take it back a slide to the last video where we calculated the mean of a variable from a frequency distribution. And yeah, you probably hear my dog in the back barking at the kids running up and down the street. So you'll probably hear the dogs in a lot of videos. All right, so we're going to use the same chart in just a minute, but on the last video, we calculated the mean, and this was our formula. And since it's a sample mean, we used X bar. Had it been a population mean, we would use mu. So our mean for this frequency distribution is 14.8. And if you recall, we made ourselves some columns. In addition to the column of class, there was also a column of frequency, and we added that whole column up. There's also the midpoint of each class. And if you recall, you get the midpoint of a class by adding the lower bound of the first class to the lower bound of the second class. So 10 plus 12 divided by 2 is 11. 12 plus 14 divided by 2 is 13, etc. Those calculations aren't quite so cumbersome. Then we took and multiplied the midpoint of each class times the corresponding frequency, and that gave us this column, XI, You're just multiplying. And then, of course, we added that column up, plugged it into the formula, and that's how we got the 14.8. If you didn't catch the last video on this topic, it's posted, so if you need more explanation, I would view that one. Now, to get the variance, we need the mean. So this is the same chart, it just looks a little fancier and typed up because I copied and pasted from the textbook. Again, you have the ebook, and you really should be focusing on pulling out these directions from the book and not just trying to go out and tackle the homework without looking at anything, because they really do a good job of breaking it down into steps. So I'm actually looking at page 163. I'm not going to write the steps because they're on page 163, and I'm not going to read the steps. I'm just going to explain what's going on here, and then if you wanted to have it open next to this video, that would be a good idea. All right, again, we've already found the midpoint. The frequency was given. There's the mean, and we need to add some more columns. So the next column we're going to add is XI minus X bar, which sounds like Greek. And that just, remember, this is your XI column. XI is just your midpoint. X bar is just your mean. So we're going to take 11 minus 14.8, and we get negative 3.8. We're going to take 13 minus 14.8. Minus, that didn't really show up, did it? And we get negative 1.8. And I noticed when I'm working out the homework and I'm on my notebook paper, there's a lot of data in these columns. So I found it very helpful to take my highlighter, especially for calculating this column, and highlight the numbers I need. Now, it can also be very frustrating if you don't get the calculations correct, because like we said in the last video, one wrong addition or subtraction and the whole answer is wrong. So I know that's frustrating, but it's also going to make you kind of double check over your information, because you won't have second and third chances on the test or the final exam. All right, so continuing this, 15 minus 4.8 is going to give you 0.2, and then 2.2, and 4.2, 6.2, and 8.2. Then we're going to take that information, let's make another column. Say we probably need a line right here. There we go. And look, I could probably make this a little nicer. Perfect. Now, this last column is going to have the most work in it. You're going to take xi minus x bar squared. And then you're going to multiply it by its corresponding frequency. All right, so I'm not going to show all the calculations for each one for lack of room, but I think you'll understand exactly what I'm doing here. All right, let me change colors. Xi minus x bar, that's the data in this column. We're just going to take those numbers, square them. So that's going to be negative 3.8 squared times the corresponding frequency, which in this case is 6. And that's going to give us 86.64. I'll show you again. We're going to take x minus x bar and square it, negative 1.8 squared times its corresponding frequency, and that's going to give us 45.36. All right, now this is the part you really need to watch out with your numbers, because I'm telling you, I got a little aggravated because I didn't have a calculator at work, and I was using the calculator on the computer to check some things, and it's just not the same. So I definitely invest in a good calculator that you're comfortable with. All right, this next one is 19.36. Then we've got 52.92. And then we've got 0 and 201.72. All right, then we're going to take and add up this column right here. That notation is the summation of x minus x bar squared times the frequency. We add all that up and we get 406.4. All right, now our formula for variance, sample variance, S squared, just like it's always been, is equal to the summation of x minus x bar squared times f, all divided by the summation of f minus 1. So again, that's kind of like that degrees of freedom we saw in -1 when we did variance of a set of data. But this is a little bit different, remember, because we're dealing with a frequency distribution. We're not dealing with every piece of data. All right, we've already done all this stuff in these columns, so we don't have a lot of work left to do at all. All right, right here, that's this right here. So we're going to plug in 406.4 divided by, okay, down here, well, let's use green. We've added up the frequency, that's this, 40, so this is going to be, that's 40, take away 1, so we're going to divide by 39, and we get approximately 10.42. So that's the variance, and then just like before, to get the standard deviation, you take the square root of that. So the standard deviation, S, is equal to the square root of S squared. So that's the square root of 10.42, which is approximately 3.23. And remember, we like the standard deviation because when we plot this, we can tell 3 standard deviations to the right of the mean and 3 standard deviations to the left of the mean. And then we can also go back to section 3.2 and apply that empirical rule, which states 68% of the data lies between 2 standard deviations, or I guess 34% lies between one standard deviation to the right or to the left, however you want to look at it. But it's basically the 68, 95, 99.7 rule. So that rule is actually on page 152, 151, and 152. And that's all you're doing right there for sample variance of a frequency distribution and sample standard deviation.